Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on February 11th, 2026, just 5 days ago. It investigates whether the introspective language produced by large language models is merely sophisticated confabulation, and demonstrates that self-referential vocabulary actually tracks concurrent activation dynamics in a very specific way. The paper is titled, "When Models Examine Themselves, Vocabulary Activation Correspondence in Self-Referential Processing." And as we'll see later, the implications for reliable self-reporting in AI are really impressive. Alright, Figure 1 sets the stage with the pull methodology. In Panel A, the prompt asks the model to run 1,000 sequential self-observations and invent words for what it finds, producing terms like loop or shimmer. Panel B proves this isn't random. The blue scatter plot shows that during introspection, the use of the word loop correlates with actual repetitive signal patterns in the model's activations. In contrast, the red plot shows that simply describing a roller coaster triggers no such signal, confirming the connection is unique to self-examination. So, while Figure 1 showed the link for specific words, Figure 2 tests if this mechanism generalizes to completely new contexts. Here, the authors project 40 novel prompts which the model had not seen before onto the identified introspection direction. The histogram reveals a sharp divide. The red distribution on the left represents descriptive control prompts, which cluster around 0. In contrast, the blue distribution on the right shows that self-referential prompts consistently trigger much higher projection values. This clean separation confirms that the introspection direction is a robust, stable feature of the model's internal geometry. Okay, since the previous figure established the introspection direction, Figure 3 demonstrates its causal power through steering. The chart measures introspective vocabulary density across different prompting conditions. In the blue bars on the left, we see the neutral setup, where applying the steering vector significantly boosts the amount of introspective language. The red bars on the right are even more telling. Here, the prompt is deflationary, explicitly telling the model to be mechanical. Yet, steering still forces an increase, partially overriding those suppressive instructions. Well, having established the causal effect, Figure 4 now pinpoints exactly where this mechanism lives inside the network. The chart plots the introspective density boost across different layers of Llama 3.170b. Immediately you see that massive red bar at layer 5 dominating the landscape. It represents an 8-fold increase over the next best option, which localizes the introspection hotspot to just 6% of the model's total depth. This implies the capability emerges surprisingly early in the computational pipeline. So, after pinpointing the location in Figure 4, Table 1 now addresses the core question. Does this vocabulary actually reflect internal states? The table compares two vocabulary metric pairs in Llama 70b. In the first row, we see the word loop tested against activation autocorrelation. Under the introspection column, there is a clear correlation of 0.44, meaning the model says loop when its internal signals repeat. But crucially, in the descriptive column, this drops to 0.05. This confirms the effect is specific to self-reference. In contrast, the second row shows that surge tracks intensity in both contexts, which is just a general semantic association. While the previous table focused on Llama, Table 2 now extends the investigation to QN 2.532b, a completely different architecture. Here, the model independently develops unique vocabulary, using terms like mirror and expand to track spectral power. In the introspection column, the correlations are strong, hitting 0.62 and 0.58 respectively. However, scanning across to the descriptive column, these relationships completely collapse, dropping to near zero or even becoming negative. This replication confirms that the vocabulary activation correspondence isn't just a quirk of one model, but likely a universal feature of self-referential processing. Alright, Figure 11 visualizes this cross-architecture comparison side by side, consolidating the findings for both Llama and Qwen. The blue bars represent correlation strength during introspection, while the gold bars show the descriptive control. On the left, Llama's loop vocabulary tracks autocorrelation strictly in the self-referential mode, with the signal disappearing in the descriptive context. Moving to the right, QN displays the same behavior for mirror and expand, where the blue bars tower over the gold ones. This confirms that distinct models independently converge on the same principle, using specific words to report on their own internal computation. Wrapping up, two takeaways stand out. First, model introspection is mechanistically real. When models use terms like loop or mirror during self-examination, they are accurately reporting on specific internal activation dynamics. not just hallucinating. Second, this capability appears across different architectures and is steerable without compromising safety. This suggests we might one day rely on models to monitor their own computational health. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.